If I take a pressure washer and change the nozzle on it, why does one nozzle spray further than the other nozzle? The Bernoulli equation states that pressure 1 over density plus velocity 1 squared over 2 plus gravity times the height of 1 is equivalent to the pressure 2 over density plus the velocity 2 squared over 2 divided by 2 plus gravity times the height of 2. So I rest the velocity 0 because the power washer isn't used, eliminating the kinetic energy term. On both states, the elevation does not change and gravity stays constant, so the potential energies equate to each other. Therefore, we are only left with pressure 1 over density equals pressure 2 over density plus velocity 2 squared over 2. So the pressure in the pressure washer is determined, and in state 2, it's atmospheric. So the only thing that the nozzle changes is its velocity of the water shooting out. This is due to an area of nozzle affecting velocity. So the answer, therefore, is that the nozzle sprays further because its velocity is different, leaving the nozzle. For my calculation problem, I take a cylindrical water basin open to the atmosphere, and it has a full height of 20 centimeters. I open the drain along the base, and it begins to drain horizontally into another open container to renew the water in the basin. What could be the max velocity of the water draining? So what is known is this diagram, which shows that Z1 is equal to 20 centimeters, Z2 is 0 centimeters. Uh, the starting velocity will be 0 in V1, and the density is 1,000 kilograms per meters cubed. So we need to find velocity 2, which is the velocity at the drain, and its maximum value. We can assume that pressures are equal because they are both open to atmospheric pressure. We can assume flow is incompressible and irrotational, except at the walls of the basin, which is negligible. The drain is slow enough to be approximately steady, and the irreversible loss at the drain can be neglected. So the plan is to write out Bernoulli's equation, rewrite it for ease of manipulation, simplify it, rewrite to find the variable needed, and then plug in the values and solve. So my solution below shows me taking out the pressure, or sorry, multiplying the gravity across both sides of the equation, or dividing the gravity on both sides of the equation, sorry, which then we can equate the pressures over density times gravities, because they're going to be equivalent because the pressures are atmospheric. Then we can eliminate the kinetic energy term on the state 1 because the velocity is going to be 0, which equates that value to 0. So we're left with the z1 is equivalent to v2 squared over 2 times gravity plus 0 because the z2 is at 0. Therefore, we can then are left with z1 equals v2 squared over 2g. Then we can rewrite it to get square root of 2g z1 equals v2, and we get an answer of 1.98 meters per second after converting all of my units. Overall, this is a reasonable because the drain would just drain out and almost immediately.